Because the Earth absorbs and stores much of the energy it receives from the sun as heat, underground temperatures remain at a constant point between 5 and 42 degrees Celsius year-round depending on where you are in Canada. A geo-exchange system can use this energy source to economically heat and cool almost any kind of building, heat water, provide refrigeration, and perform many other applications. During the winter, a geothermal system absorbs the heat from the Earth and transfers it into your home. During the summer, the system takes heat from indoors and moves it back underground. A geothermal system is made up of three components: a heat pump, usually located inside the building where it is protected from the environment and vandalism, an underground heat exchanger to act as a heat sink to store energy in the earth when cooling and to extract energy from the earth when heating, and a distribution system, such as air ducts or hydronic radiant floor tubing to provide comfort control for the building space. Hydronics means using water as a heat transfer medium. The two types of heat exchangers commonly used are open loop and closed loop. A closed loop uses a system of continuous underground pipe loops in which both ends of the pipe system are connected to the heat pump, thereby forming a sealed closed loop. Water, or a mixture of water and environmentally friendly antifreeze, circulates through the loop to transfer heat between the heat pump and the earth or return heat back to the earth. In some installations, the pipes of a closed-loop system can be placed in a horizontal trench dug below the frost line. The number of pipes in each trench and the number of trenches needed will vary depending on the size of the geothermal system being installed and the type of soil found in the area. In locations where space is limited or a large heat exchanger is required, the pipes of a closed-loop geothermal system can be installed vertically in welds drilled into the earth. In an open-loop system, on the other hand, groundwater from an aquifer well is pumped from one well and passes through the heat pump where heat is added to or extracted from it. The water is then discharged back to the aquifer or harnessed for other water management uses. Because the system's water supply and discharge are not connected underground, the loop is open. There are economic and environmental benefits and costs to the use of geothermal heat pumps. While the units are expensive to install, many governments provide grants to subsidize the cost. A heat pump is very quiet and the operating cost is only 40 to 50% as much as using conventional fuels. Lower energy consumption also means reduced greenhouse gas emissions. This decreases the need to consume fossil fuels and electricity. Furthermore, since no combustible fuels are used, there is less chance of explosion and concerns over indoor air quality are reduced.